So in the previous videos, we've talked about how to express the concentration of a particular solute or a particular ion in a solution. But how do you actually prepare solutions, specifically in the chemistry lab? How do chemists prepare solutions? That's going to be a skill that you will use this semester, particularly in Experiment 7 and in the Beer's Law experiment. So let's talk a little bit about how to prepare a solution, and then we're going to use those skills and that knowledge in talking about doing dilution problems and then problems that are on the concept and the technique of titrations. But first, so if we were to prepare a particular solution in the lab of a particular solute, we would first weigh out the appropriate solute. So we weigh out a particular amount. We would calculate that mass from the molarity, and though we'd know the number of moles of our solute, which is shown here on this little filter paper. We would add that to something called a volumetric flask. This piece of glassware here with the yellow and blue stopper. This volumetric flask is sort of similar to the volumetric pipettes that you used in the first experiment, in that they are calibrated to the 100th decimal place. And when you add water, so you add your solute, and then you add water to that flask to a particular line that's on the neck, and that solution is calibrated to the 100th decimal to the volume specified on the flask. In this particular instance, we have a 250 milliliter volumetric flask. Once we add enough water to that flask so that the bottom of the meniscus hits that mark, we have 250.00 mils of solution. And then we take that volumetric flask and shake it so that our solute dissolves. So many times preparing a solution will involve weighing out your solute, putting that solute in something called a volumetric flask, and then adding the appropriate amount of water and shaking it to dissolve your solute. Many times, and you will do this actually in the Beer's Law experiment, many times you will need to make a solution, but then make dilutions of it. So what that means is you'll have something called a working solution, or something of a known high concentration, and then you'll need to make dilutions of it. So make solutions that have smaller amounts of that solute. And so, you know, as chemists, we like to be particular, but we also like to be lazy when at all possible. So let's say we needed to make 4 different solutions of the same solute, but of different concentrations. So we could weigh out a different amount of solute 4 times and then do 4 different calculations. Or we could be easy, we could be lazy, and make a solution that is concentrated, and then instead of weighing out 4 different amounts of solute, calculate how much of this concentrated solution we would need to dilute to get a more dilute solution. So many times chemists use a dilution method if they need to make a bunch of different solutions that are of a smaller concentration from a known stock solution. And doing that can be fairly handy. You don't have to weigh as much stuff out at the balance, and it's a lot easier to pipette certain smaller amounts of a stock solution and then add water than it is to weigh out certain amounts of solute each time. So take home, and we're going to talk about the equation that is used to do dilution problems shortly. But the take-home message from this slide is that essentially when you have a solution and you dilute it, obviously your diluted solution the concentration is going to be less than your stock or your initial solution. And so the equation that is used to express or to calculate dilutions is this equation called M1V1 equals M2V2. Now in your MindTap, let me get my little pen here, in your MindTap homework, they use the terms C1 and V, or they use the terms C and V, C being the molarity, V being the volume. Either one is fine. We'll do examples in the next video using both. But essentially, to determine the concentration of a solution from a dilution, you can use this equation, M1V1 equals M2V2, where your M1 and V1 refer to the stock or the initial solution, so your more concentrated solution, specifically the concentration and the volume. And M2 and V2 refer to your final or diluted solution. I believe in your MindTap they call this C concentrated, V concentrated, C diluted, and V diluted. We will do examples using both, but in short, when doing dilution problems or when taking a concentrated solution and making a dilution, you can determine the molarity or the concentration of the new solution by this equation, M1V1 equals M2V2. And so in the next video, we are going to do this problem along with another one to solidify this concept of dilutions.